Yes, Brenda? Yes, Baptist. Baptist? Yes, members. Yes, my students, are you getting me?
Sir,
Yes?
excuse me, sir.
Yes, Apira, you had a question before we went for the break. Yes?
Sir, I didn't get the explanation of the graph. I was disturbed by the network.
Okay. On the
The
graph,
explanation of the graph.
okay. On the graph,
I
here,
didn't get it.
here we are comparing. Now you listen, okay? Okay? We are analyzing the effect of friction between the force applied and the force applied on the body and the friction itself and the frictional force itself. So we are saying for solid friction, the force applied will be equal to the frictional force. So which means if you increase the force applied, you will also increase the what? The frictional force. That's why you see the graph is running, is proportional. That's why we are putting it here, is proportional. So which means if you increase the force applied, you are also increasing the solid, the static friction. But for kinetic friction is the opposite, is the opposite. As to increase because it does not depend on the velocity, because kinetic means something in motion, something in motion. But we have also seen that kinetic friction, friction does not depend on the relative velocity of the two surfaces in contact. It depends entirely on normal reaction. It depends on the normal what? On the normal reaction rather than the speed. That's why you see now, it gave us this formula here. So it means as the speed is increasing, it is what? Is inversely proportional. So if you increase in the speed, instead the frictional force is reducing. The force is reducing. Like you can see, that's why we are able to drive. It does not mean that there's no frictional force, but the frictional force has become so minimum to the extent that it will keep on decreasing as you drive. Like if you are driving a car, like if you are riding a bicycle, okay? But for solid, for static friction, if you increase the force applied, you are also increasing the what? You're also increasing the static friction. But for kinetic, as you increase the force, the force applied F, the frictional force keep on reducing, keep on what? Decreasing. Have you got it, Apire? Have you got it? Apire? Apire? Yes, Apire. Okay. So what explanation do we give for this? Explanation. Explanation. So explanation using kinetic theory of matter. Explanation using kinetic theory of matter. Explanation using kinetic theory of matter.
Yes, sir.
Explanation using kinetic theory of what? Matter. So we want to explain the laws one by one, one by one. So the first one we are saying the actual area of contact of two surfaces is very small. Is very what? Small. Hence the pressure at the point of in contact is very high. We remember that pressure in solids. The smaller the cross-sectional area, the bigger the pressure exerted. So here we are also saying because the two surfaces are in contact. The two surfaces are in what? Are in contact. The two surfaces are in contact. The two surfaces are in what? Are in contact. So take for example, we have this, we have this, we have this. There's a block there resting on that. We have that, we have that. So you find that the area of contact here is very small and frictional force act at the surface, So for the purpose of sketching, so if the body is, if you are pushing it in this direction, yeah, so which means we are sliding it. So we said frictional force does not depend on the speed, or the relative velocity between the two surfaces in contact. Instead, it depends on the what? In the normal reaction. It depends on the normal reaction. And we said for this one to be experienced, normal reaction must remain constant. And we know that normal reaction is equals to M what? Normal reaction is equals to mg. So this is our frictional force. And frictional force is given by mu r. Frictional force is given by mu r. And this one is at a limiting friction. This is at limiting friction. At limiting friction. Limiting mean we said is the maximum frictional force between two surfaces in contact. Okay, and provided the normal reaction remains constant. So at limiting friction, frictional force will be equals to mu r, where mu is the coefficient of friction. Mu is the coefficient of what? Friction. Is the coefficient of friction. Then r is the normal reaction. R is our normal reaction. So now we are explaining using kinetic. We know that solids are made up of small molecules or of small particles. And these are the particles which make up the solids, which makes up the solid. Now we want to see how do they behave when there's a friction, when there's frictional force between them. Like we have seen from the video here, that you can see from the video here, members. Let me take you back here. Let me take you back here. Like you can see from here. The surface is very small, very small. And that smaller cross-section area will exert a greater pressure. Will exert a greater pressure on the surface. That's what I'm trying to explain using kinetic theory of matter. So what we are explaining is here. Only that they have zoomed it big here so that you can see between the two surfaces here. You can see it's zigzag. It's not flat. It's zigzag. That's why it experiences the frictional force. So here is, in the actual sense, it seems to be zigzag. It's like this. That's why there's friction there. That's why there's friction there. So you find that there's a small wheel there, very small cross-sectional area, very small cross-sectional what? Area. And that small cross-sectional area will produce a greater pressure. Will produce a greater what? Pressure. So now we are saying the actual area of contact of two surfaces is very small. Hence, the pressure at the points of contact is very high. The projection might to produce welding. Now it will give what we form what we call now welding. There's going to be welding here. Welding. So they find that they are merged together. Welding means they are merged together. They are what? They are merged together. Are we together, members? Are we together? Sandra? Sandra?
Yes, teacher.
Are we together?
Yes.
Okay. All right. So, and that one explain the first law. Explain the first law. Why why frictional force opposes motion? Because of the zigzag, we find that they will be welded together. The two surfaces will be what? Welded together. So there will be no motion. So it will oppose motion. Okay? And we say that frictional force to be exerted for a body to move, the force applied must be greater than the frictional force for a body to move. The force applied, if this is the force. So for this body to move, this force F must be greater than, must be greater than the frictional force MR, must be greater than that. Otherwise, the body will not move. So this body will remain at rest if frictional force, if mu R is greater than F, So it must be like that. And we are able to move because of frictional force. That explains the first law of frictional force. What about the second one? We are saying that the area of contact is small and the actual area of contact is the same. It will not change. It will remain the same throughout here. And that now we say that frictional force does not depend on the area of contact. We are explaining that. Then the third one, increasing the weight. Increasing the weight increases the pressure at the wheels. So when you increase, when you pile up, you get another block, you add on this, you keep adding, you keep piling weight there. Because you keep adding the what? You increasing the normal reaction. Because normal reaction depends on the mass of the body or on the weight of the body. Are you together? So if you keep on increasing the weight, you're also increasing the normal reaction. So at that point, we are saying now, frictional force is directly proportional to the normal reaction. It's directly proportional to the normal reaction. So increasing the weight increases the pressure at the wheels, and hence a greater limiting frictional force. This explains the third law. This explains the third law. Members, if there's any question, ask me before I proceed. Before we proceed. Is there any question? Is there any question so far? Is there any question, members? Apire. Apire. Is there any question?
Excuse me, sir.
Yes, please.
Excuse me, sir.
I'm getting you, please. I'm getting you.
Excuse me, sir.
Your network, I can't hear you.
I beg
Brenda.
you to first.
Yes, Brenda.
The first law. First
Brenda.
molecular experiment.
Brenda.
Yes, teacher. Yes, teacher.
Are we together,
Excuse
Brenda?
me, sir.
Teacher, I didn't get you on the graph.
On the graph. Now we are through with the graph,
Yes.
Brenda. We are through with the graph. This graph here. On this graph.
Which graph? I'm not seeing.
You are not seeing?
I'm not seeing the graph. It is not on the screen. Yes, that graph.
Okay. This one we are explaining. Now I've explained it. You people, you are making us just to keep going back on the same thing. What's the problem? Network what?
I joined
Now I'm just repeating the same thing time and again, the same thing.
late.
I'm explaining the same thing. It's almost for an hour now. Let's be attentive, please. Let's learn to keep time if there is time for lesson. Okay?
Okay.
Yeah, let's learn to keep time. So in this graph, we are explaining the effect of different type of friction. So here we are looking at for solid friction. This one is for solid friction. Here is for, it's for static friction. This is static. So for static friction, the force applied is directly proportional to the. It means when you increase the force applied, you also increase the what? The frictional force. Okay? Are together? But here, as we increase the force applied on the system, the frictional force keep on reducing. The frictional force keep on what? Keep on reducing. So it's not proportional. It's not proportional. It's not what? Proportional. Have you got it, Brenda? Have you got it?
Yes, teacher.
Okay. So now we want to see how do we determine the coefficient of friction. So how do we determine this? Because we said frictional force F is equals to mu R. So how do we determine this coefficient of friction? How do we determine mu? How do we determine it? How do we determine it? So let's look at that. Experiments. Let's look at experiments. Experiments. Let's put it in form of question. Let's put it in form of question. Describe a simple experiment. Describe a simple experiment. Describe a simple experiment to determine the coefficient of friction. To determine the coefficient of static friction. To determine the coefficient of static friction. To determine the coefficient of static friction. There are two methods here. There's two methods. Method one. This one is a inclined plane. This one we use incline what? Inclined plane. Inclined plane. So can we sketch it? Can we sketch it? Inclined plane. So it's raised to a given angle theta. So I can put it like this. There's no problem with that. Sorry, let me use a flat surface so that it get into contact. Let me use this one. Let me use this. Brenda, who is that? Is it Brenda? Brenda?
Yes, teacher.
Was that you sneezing?
No.
That was serious. We know this. There's always that component which acts downward. This one we know it. So this is md sine theta. Sine theta. So is rolling down, which means frictional force must be acting upward. Frictional force must be acting upward. Frictional force must be acting upward because it opposes the motion. So they move in opposite direction. They move in opposite direction. They move in opposite direction. So this is our frictional force. So this is going to be our frictional force, F equals to mu R. Mu R. And it must be between the surface. Don't put it in space. Put it on the surface. So how do we do the experiment? How do we go about this? So the first thing is, place an object, in bracket, a block. You can use a block on a horizontal plane. On a horizontal plane. That's the first thing we will do. So you first get a body like this one here. Let me try to demonstrate it here. Let me see what can I use to demonstrate. So like if I want to determine the coefficient of friction between these two, this one and this. So I first put it like this, then I start tilting it at the given angle. I start tilting it like that. Then until this block slide a bit. So that when it slides, that's when I will stop. You find that you are raising it to a given angle. You are raising it to a given what? To a given angle. So that's the first thing. Place an object or a block on a horizontal plane. Then displace. How do you displace? By tilting. By what? Tilting. So tilt the plane, gently. Tilt the plane gently until it adjusts. The key word there is just. Until it just begins to slide. And until it just begin to slide. That's the next step. After that, measure and record. Measure and record the angle of tilt or the angle of inclination. Measure and record the angle of inclination, in bracket angle of tilt, theta, to the horizontal, full stop. Now, how do we determine, after measuring that, how do we determine from that? Let's prove that. So when we resolve along the plane, resolving along the plane, resolving along the plane. So when you resolve it along the plane, what do we get, Brenda? What do you get when you resolve along the plane? You find the frictional force will be equals to what? MR, not so?
Yes,
not
teacher.
So? So you find the frictional force F
Yes.
will be equals to mg sine what? Mg sine theta. But we have said F is equals to mu. F is equals to mu what? Mu R. So which means we shall have mu R is equals to mg sine theta. Also, you should note when you resolve perpendicular to the plane, what do you get? R is equals to mg cos. Not so? R is equals to mg cos theta. Now you find that we shall have mu, let me call it SS, static, mg cos theta equals to mg sine theta. So divide all through, we are looking for this one, coefficient. So divide all through by m cos theta, divide all through by m cos theta. So this and this will disappear. So you find mu will be equals to this and this will disappear. Then we remain with sine theta over cos what? Cos theta. What is this one? Members, what is that? Sine over cos is what?
Tan theta.
So therefore, our mu will be equals to tan what? Tan theta. So that's how we determine that. So that's how this one came about. So we're saying, therefore, the coefficient of friction is equals to tan what? Tan theta. Okay? Are you together, members? Are we together? Members, are we together on that?
Yes.
Good.
Yes, teacher.
Good. So from there, they did not show you how they got tan theta, but I've already shown you how tan theta came about. Okay?
Yes.
Let's look at method number 2. Method number 2. And method number 2, this one, I think you did it in O level. In O level. So here, you get a table, horizontal table. So we are assuming that is a rough surface because we need friction. Then you get a pulley to help you do this. Then we have a block. There's a block there. A block there. We know there's going to be weight. This block is going to exert weight on the, so this weight is mg. There's also going to be normal reaction there. So that's our normal reaction. Then it must be, this one you must connect it to the, the scale pan, which is here like that. So this is our scale pan. Then we keep on adding masses there. We keep on adding the masses there. So there's tension here. There's tension T. Then there's also tension there, T. So where this thing will move in this direction, it will slit in that direction. So which means frictional force will be this side. Frictional force will be in this direction. They must be in opposite direction. So this is it. MSR. That's our frictional force. So how do we go about the surface? How do we go about the procedure? Sorry, what are the procedures? So this is the scale pan. This is a fixed pulley. Then this is it. This is a rough horizontal surface. Like that. So the first step, the mass M of the wooden block, is determined and placed on horizontal plane surface, like you can see from our diagram there. Then a string is attached to the block and pass over a smooth pulley. Because we don't want to again, because there's going to be friction if not smooth, but only that we want to determine the friction between the rough surface and the block, the two surfaces here which are in contact. So this one must be smooth to minimize on errors and actually to improve on the accuracy of our experiment. Over a smooth pulley carrying a scale pan at the other end. So we have the scale pan here, Then small masses are added to the scale pan one at a time. So you keep on adding the masses here, one at a time. Why do we add the masses? We add the masses because we want it just to slit. Remember here we said just to slit. Just to slit or just to move. Then the mass M. The mass M now, capital M is the mass of the scale pan. Capital M is the mass of the scale pan. This one is M. This one is mass M. Of the scale pan, and the mass is added is obtained. Then the coefficient of friction. The coefficient of friction. The coefficient of friction. I think that the coefficient of friction is going to be small m over capital M. Where is this one coming from, members? Where is it coming from? Let's prove that. That's what I want to show you, that because this one you can read them. Where is this one coming from? It's coming from here, from the definition of limiting friction. So we're saying at limiting friction, frictional force F is equals to mu R, is equals to mu R, is equals to mu R. And remember, in this case, the frictional force will be the same as the tension, will be equal to as the tension. So you find that there's going to be weight here. There's weight acting here, members. This is it. This weight is M what? Mg. So in this case, if I'm to resolve this, you find out that the frictional force will be equal to the tension, will be equal to what? The tension T. And this tension is equals to this. Is equals to this. If I'm to get the resultant, it will be equals to this. So you find out T is equals to mu SR, will be equals to that. Will be equals to that. So which means now my frictional force, my frictional force. So MSR is equals to, but we say T also T is equals to mg. T is equals to mg. So which means we shall have capital M G, which is this one here. But members, what is R? R is what? What is R, member? R is what? R is it? Members, what is R? R is what? Mg.
Mg.
R is Mg. So you find out we shall have Mg is equals to the capital M. So you find that the G and the G will cancel out. Then you find that we shall have SR equals to capital M over small m. Should be like that. They have changed. Should be capital M over small m. They have reversed it. Okay?
Yes.
Should be capital M over small m. So that's how this one came about. So it's going to be mass of this over the mass of the block. Are we together, members? Are we together? Sandra?
Yes, teacher.
Are we together?
Yes.
Good. What about Brenda? Brenda, are we together, Brenda?
Yes, teacher.
Baptist, are we together?
Teacher.
Yes?
Last year when I think, if I'm not mistaken, I think it was a paper for those guys who sat last year. Then I saw some question about friction, but it was quite challenging. I've forgotten it.
It was
I don't know if you can get that paper.
I need to check.
Yes, if it's not in that paper, then I think it is in some more paper which I've forgotten.
What was it asking specifically? What was it generally? What can you recall from the question?
I can recall, there was one which was requiring to work out. Then there was one experiment, and then I looked for it, but I failed to get that experiment.
Okay, I will check and then get back to you.
Yes.
I think I have the question papers there. So that is how we determine for what? For static friction. What about for kinetic friction? For kinetic friction, the experiment is the same.
Sir.
Yes? Yes, please. Yes? Yes?
Excuse me, sir.
Yes, I'm getting you. I feel your problem, your network is not stable. Your network, I can't get you. I can't get you. For kinetic friction, you keep on adding the difference between this one and kinetic friction. For kinetic friction, you add until it move with a uniform motion. Okay? The experiment is the same, but you keep adding. Small masses are added to the scale pan one at a time until the block move with a uniform speed. Until the block move with a uniform what? Until the block move with a uniform speed. Are we together, members? Are we together? Members, are we together? So that's the only difference here.
Yes, sir.
Yes. Yes.
Excuse me, sir.
Appear, I can't get you. Your network. Yes, what are you saying? Yes. Yes, please.
Yes, sir.
I'm getting you. Talk, please.
I think what Namuli was saying, she was
Yes.
they were asking for the frictional force experiment to determine frictional force, not the coefficient.
Experiment to determine what?
The frictional force, not
The
the coefficient of friction.
Now, in that question, that one you pick any, because kinetic friction is divided into two. Okay? Okay? Friction is divided into either static or kinetic. So now what you can do, if the question is straightforward like that, you pick one of the experiments. You can either pick for static friction or for kinetic friction. But the only difference in this experiment, for static, members, the only difference in this experiment is that you have to, for static, you do until it just begins to slide. But for kinetic, you keep on adding the masses until it moves with a uniform speed. Are you together? Until it moves with a uniform what? Until it moves with a uniform speed. So members, our time is running out. But
it was, they were saying to
yes,
determine the static friction.
the static friction, the coefficient of static friction, eh?
Not the coefficient of static friction.
It's still the same, because you can only determine the coefficient of friction if you know the coefficient of static friction. So it's the same equation. It's still the same. It's still the what? The same. You pick one of these two experiments. Okay?
Yes.
Yes, it's the same. It's the same. Members?
Yes.
I think when we meet on Saturday, we shall do the calculations. When we meet on Saturday, we shall do the calculations. Okay?
Yes, sir.
Yes.
Yes. So we'll do the calculation because our time is running out. We can't do the calculation now.
Also check about that question. Don't forget.
I checked the question.
Don't forget to check on that question which I have told.
Okay. I'm going to check it now even so that I put it in. I add it on this book. Okay.
Okay.
Members, have you understood? The definition of friction? The laws, the three laws, and how to explain them using the kinetic theory of matter, and how to determine the coefficient of friction. Have you understood all those three concepts?
Yes, sir.
Okay.
Sir.
Yes.
1 minute.
Yes.
1 minute left.
Yes, please.
Because for me, I understand the first law explanation.
The explanation.
For the first kinetic explanation.
The first law, what does the first law state? Can you state for me the first law? What does it state? The first law of solid friction, what does it state?
Opposite
frictional force
opposes relative motion
between two surfaces in contact, no, sir?
Yes.
Now the kinetic, we are looking at the molecules. We are looking at the what? We are looking at the molecules. Let's show you from here. So we're saying frictional force, the actual area of contact of the two surfaces is very small, because you just see, the two surfaces is very small. It's very what? Small. Let me show you from here. I think this video here. I think this video here.
Yes.
Now, when you look from there, so I think this bigger part. I think this bigger part here. This one here. This one is, we have just zoomed in, because when you zoom in this small part here, this small part here is what, this is what you see when you look at it with a microscope. Okay, because it's very small. The area is very small. You find that the area is not flat, it's zigzag. That's what is creating that friction, is zigzag. Okay.
Yes.
And we're saying that area is very small, and we said the smaller the area, the pressure what? The pressure exerted is very what? Is very high. Okay. The pressure is very what? Is very high. And because that area is very small, it will create what we call welding. It will create what? The welding. They will be merged together. They will be merged what? Together. Are you together? And that's what,
Yes.
and that's what make that what will make the what? The body not to move over the one another, not to move on. And in that case, now it's opposing the motion between the two surfaces. Okay.
Yes.
All right. Have you got it now? Have you got it, members?
Yes, sir.
Okay. So can I wish you a good day?
Yeah.
Okay.
Sir.
Okay, bye. Bye.
Bye.
Bye.
So on Saturday when we meet, we shall do strictly calculations. Strictly what? Calculations. Okay?
Yes.
Yes. Okay, have a nice day.
Likewise.